Okay, so now let's start looking at the question that's a little bit more complicated. Take a look at this one. Here's another linear function right here, which is 3x minus 4. Do you remember your mx plus b? Yeah, your y equals to mx plus b. There's the slope. There's the y-intercept. So the y-intercept is at negative 4. Check this out. 1, 2, 3, 4. There's your negative 4. Now, this is rise over run. So that's 3 over 1. So you rise 3, 1, 2, 3, you run 1. So your line should look something like this all the way down, about like that somehow. Okay? Very, very rough sketch, but at least that gives you an idea. Now, here's the cool thing now. We have to do the absolute value function. Well, wait a second. All I can remember is that anything above this means that it's negatived or absolute value, or in grade 8 we called it the mirror, or in grade 11 here in math 20 we call it the flip. So what we're going to do is check this out. I'm going to take this y-intercept that we know is negative 4. I'm going to take the absolute value of this. Check it out. 1, 2, 3, 4. There's my new point, and guess what? That's exactly how my graph is going to go. It's going to go out this way. That's going to be my absolute value function. So check this out. I'm going to show you this on the computer so that you can actually see this. So here we go. Here's my calculator. I'm going to clear this. I'm going to go my y equals 2, and I'm going to clear that real fast. Now, I want to put an absolute value, okay? I want to put this in, absolute value. How do I do that on my calculator? Well, very, very simple. Put my y equals 2 button there. But now I got to put absolute value. Do you see this right here? Do you see this math right here? Perfect. All you have to do is hit it, math. Then it comes over and you mouse over to the right to NUM. NUM stands for number. What are you going to do with the number? And look at the first thing that comes up. ABS, that's absolute value right there. Just hit enter. Now, in some calculators, it'll actually look like absolute value sign. In this particular calculator, it says ABS and bracket. Whoop-de-doo. Put in 3x minus 4 and put a bracket around it. Check this out. Graph it. Boom. There's the absolute value function that I just graphed to the right. But what does this mean? This means, look, this line that was right here is just reflected, like on the mirror, reflected on this axis to go up this way. That's why every value here is the same. But I got a question for you. What is this value? What is this critical point? What is it? Okay. Well, it's actually really easy to figure out because think about it. Doesn't this lie on the x-axis? So isn't this, in fact, the x-intercept? Well, you bet it's the x-intercept. That's when y equals to 0. So cool thing that you can do here then in order to find it is take what was inside the brackets, this 3x minus 4, let it equal to 0 and solve for it. Add 4 to this side, add 4 to that side. Check it out. 3x equals to 4, divide by 3, bracket, cancel, cancel. X equals to, clear some room here, 4/3, which is 1 1/3, right? Look where you're at, about 1 1/3, right there. There's the 1 1/3 point. So now, if you think about this, look at your graph. Your graph is doing this, coming to this critical point, which you determine very, very simply by letting it equal to 0, and then pop straight out that way, and look what you got. You have your beautiful absolute value function. And of course, this is now your critical point. Your critical point that you determined by looking at that and making it 0, that in fact is your x-intercept. So it's really easy to do the piecewise now. Think about this. If we want to do the piecewise, we have to do this at this critical point. And that critical point, of course, has to be this 4/3. Okay? So that's your critical point. So you look at the positive side of the graph, you look at the negative side of the graph. And the positive side of the graph is going this way. Remember, so this is when x is greater than or equal to your critical point, which is now 4/3. And When x is less than 4/3. What did you do? Well, you're looking at the positive part of the graph, and the positive part of the graph is this 3x minus 4, because look, this is no different than the original line that you had here. It's exactly the same. This portion of it is exactly the same, so you haven't done anything to it. So of course, that's going to be your 3x minus 4. Same thing, the positive version of it. Now, you have to take this point, from your critical point, right here, and you have to take this graph and you have to flip it. So when you flip it, you make it a negative. Ta-da! There's your negative. The negative of this graph right here, and that's your piecewise function. Very simple, very, very straightforward. Okay, let's look at one more question and let's see if we can figure this guy out. Take a look at this one now. Take a look at this one, minus 3x minus 6. So without using the calculator, let's see if we can figure this out. Minus 3x minus 6, first thing I would do is I would remember my y equals mx plus b. And I'd remember that, there's my minus 6. That must be my intercept. So normally my intercept would be 1, 2, 3, 4, 5, 6. It would be down here. Well, and then I would rise minus 3, which rise minus 3 means go down 3, 1, 2, 3, and run 1. Oh boy. So my graph is going to look something like this, way the heck out here somewhere. Well, you know what? I don't like doing that at all. The reason why, I don't think that's very accurate. So what I'm going to do is I'm going to say, okay, 1, 2, 3, 4, 5, 6. There's my minus 6. There's my b. Okay, there's my minus 6. I'm going to absolute value that, and I know that this guy is going to come up here. 1, 2, 3, 4, 5, 6. This is now the new y-intercept because of the absolute value. Now, here's the other thing that we're going to do here now, is let's find the critical point. Well, minus 3x minus 6, minus 6. Critical point means it has to equal to 0. Add 6 to both sides, perfect. Okay, you have minus 3x equals to positive 6. Divide by minus 3, divide by minus 3. Your critical point is that x equals to minus 2. Look at that, 1, 2. There's your critical point. So guess what? That graph is going to go out this way. And look, from here, right, it's kind of like your critical point. There it is, all the way down. It's over 2. So guess what? It's over 2. Straight up there, that's what your graph is going to look like. Really, really easy to figure out, okay? So basically, this is a mirror image both ways here. Kind of looks like a parabola now, doesn't it? Except it comes to a point. All right, perfect. There's my graph. Let's prove that that is actually my graph. So let's go to my calculator. Let's go to y equals 2. Now, I'm not going to clear the absolute value out of there. Why should I clear it? Let's just put in minus 3x minus 6. That, by not clearing it and just putting in a new number, that means I don't have to go back into math and find that darn thing again. Let's graph it. Let's see what we get. And look at that. It's exactly what I drew. And if you look, this is of course at, guess where? Right up there. Looks like it's at a plus 6. If you don't believe me, 1, 2, 3, 4, 5, 6. There's the intercept. That means this intercept here is at 6 as well. So let's do the piecewise for this. Well, okay, the piecewise here is at minus 2. So remember, you have the positive version of the graph, which is this section here, which is, okay, the positive version of minus 3x minus 6. You want the positive version of it, okay? And you want the negative version of this, minus 3x minus 6. Okay, so the negative version of this and the positive version of this. But wait a second. Doesn't this mean that the slope is going down? So in fact, what you're looking at is you're looking at this portion of the graph. Aha! That's why you have to know your y equals mx plus b. So if you think about it, the positive version is actually this portion here, which is on this side of the graph. Aha! So that's when x is less than your critical point, which is minus 2. Okay, and this, which is the negative version of it, is actually this point, because this is in fact the flipped graph. Okay, so this is x being greater than or equal to negative 2. You have that. You want to prove it? I know you're saying, I want some proof. I want some proof. Remember, our original intersect was right there. This point will always be the same, whether you're talking about the intercept, okay, of the x-axis, okay, or you're talking about the x-intercept when you're talking about the line. There is the original line before we took and we did the absolute value. So that is actually your minus 3x minus 6. That's why I wanted you to see that point. This point, notice, that's kind of interesting. This point never changes, whether you're talking about the absolute value or you're talking about the line. That point will never change, that critical point. So we call it a critical point. Or we actually, because that point doesn't change, its other formal point is called an invariant point. All right, so now we've done a couple of real simple examples. Let's see if we can do and complicate this a little bit more.